All right, we're going to give you some steps to find the equation of the altitude whenever you have a triangle on the coordinate plane. You have to use coordinate geometry. There are pretty much 4 steps, or basically the 5 steps that we used before for the following. But the things that you need to remember are a little different based on the segment we're dealing with. Because we are working with an altitude, and we got to really make sure we understand what that segment is. It must be perpendicular to a side, and it has to go through the opposite vertex. So if I use that relationship to come up with my equation, because I'm talking about perpendicular, the first thing I'm going to have to do, you might need to record these steps, is to find the slope of a given side. Okay. So first we're going to find the slope of a given side. Second, because we're talking about it has to be perpendicular, you're going to need to find the perpendicular slope. Third, since it has to go to the opposite vertex, you need to start at the opposite vertex and then use the perpendicular slope to graph the altitude. I'm going to abbreviate that. All right, so just make sure we understand, because altitude is a perpendicular segment that goes through the vertex to the opposite side. We have to make sure we use that perpendicular slope starting at that vertex. Then our 4th step is going to be the same as it was for the other. Apologize for that. We're going to put it in point slope form. And when we do that, we need to use the opposite vertex, or our starting point, our vertex, and you need to use the perpendicular slope. And then last, if necessary, you're going to solve for y. Okay? So these pretty much steps that you have for each special segment are things you need to memorize and know by heart and how to apply them on a coordinate plane. So the first thing we are going to have to do on this problem is, and I don't see the points here because it was on the other side, but our points were A was -4, 1, and B 2, 7. We used the same triangle. C 4, -3. Well, now we're going to do the altitude. So we're going to plot those points. So we got -4. Go ahead and graph those like we did before. Graph them, label them, and connect them. So we have A, B, and C, and I'm going to connect them. Sorry, I have to see that one's off already. What did it let me do? Let's see. All right, so the first thing we need to do is, it says to find the slope of AB. Since we're going to find the slope of AB, I can just use my slope formula, or I can just count my rise over run. Well, if I count, that's up 6 to the right 6, well, 6 over 6 gets reduced to 1. And then the second step says find the perpendicular slope. So we need to find the perpendicular slope to that side, which would be a -1. Now, because we're looking perpendicular to AB, we have to find the vertex opposite to that side. So we have to start at C. And we're going to use the perpendicular slope to graph the line. So I'm going to start at C, and then I'm going to use or graph a perpendicular a line to AB, which is the slope of a negative 1. So I can go down 1 to the right 1, or I can go up 1 to the left 1. Notice that this line that we're graphing does not necessarily go through the midpoint. And altitude does not do that always. With special types of triangles, that is the case. So let's see if I can get this. Oops. I was trying to get a different color. All right, now you need to find we're going to sorry, not going to find. So now we have drawn the altitude. Understand that that has to be perpendicular and to the side, and it goes to the opposite vertex. And basically, you're going to do the same thing for the other two sides. So I want to start with finding the slope of the side BC. So I want to count the rise over run for the side of BC. That is actually up to 10, and to the left 2. So the slope is a negative 5. But then I want the perpendicular slope, and I know I'm running out of room here. But the perpendicular slope would be 1/5. Okay, and then I'm going to do the same thing for the side AC. So I want to find the slope of AC, count my rise over run. It's hard, I can tell looking at it, it's a negative slope. So it looks like it's down 4 to the right 8. So negative 4 over 8, which is a negative 1/2. And then I'm going to do the perpendicular slope, which is 2. So now how the slopes are for the altitudes for those sides. To write the equation of the altitudes for side AB, you're going to use point slope form of the equation. And when we use point slope form, we're going to use the vertex. So C was our vertex, and it had the coordinates 4, negative 3. And then we're going to use the perpendicular slope of AB, which was a negative 1. So we're just going to put it in point slope form, and that will give us y plus 3 equals a negative 1 parentheses x minus 4. And then we're going to solve for y. To solve for y, we're going to distribute, and then isolate the y variable. So y plus 3, I'm running out of negative x plus 4, and then when we subtract the 3, our final equation would be y equals a negative x plus 1. There's the equation for the altitude. All right, they want you to state or locate the orthocenter. Now, in order to do that, I am going to have to graph all the altitudes for each side. So I'm going to give you a moment to do that, and we'll come back to that. Just give you some time to do that. I'm going to pause for a second. All right, so to do the altitude for BC, I start at A because it's opposite. I use my slope of 1/5. So I go up 1 to the right 5, up 1, 1, 2, 3, 4, 5. And we're going to draw a line through those points. My line might be a little bit off. So I'm going to do a straight segment. And then we're going to do the same thing for AC. Since we're going to do the perpendicular slope for AC, we got to look at the opposite vertex, which is B. So that means I start at B, and my perpendicular slope to AC is 2. So I can go up 2 to the right 1, or I can go down 2 to the left 1. And draw a line through those points. Now, if you look at your graph, you're not going to have an exact point. The point is not exactly on the coordinate plane. So this is where we have to do like we did on the perpendicular bisector. We're going to create a system of equations to locate that point. So if I'll go ahead and write the equation for, let's see. Let's say I go ahead and write the equation for that altitude. So that is for AC. I'm going to write this under here. We were going to use the point B because that's our vertex. That's 2, 7. And we know the perpendicular slope was 2. So I'm going to go ahead and say y minus 7. Sorry. y minus 7 equals 2 parentheses x minus 2. And I'm going to put it into slope-intercept form. Add my 7. Get y equals 2x plus 3. Now, so now I have two system of equations. Now I can use substitution or I can use elimination. I'm going to go ahead and use elimination because I think we probably need to still review that. So in order to do that, I got to get it in standard form. This first equation, if I put it in standard form, that would be x plus y equals 1. And if I put the second equation into standard form, even though we're going to have a negative 2x, I don't want a negative 2x, so we're going to have 2x minus y equals 3. And then I can see right now, I can eliminate my y's. So this would give me 3x equals 4. Oh, forgot, that's going to be a negative 3. So it's not 4. It's going to be 3x equals a negative 2. And then divide by 3. So x equals a negative 2/3. So that's the x coordinate. And then we're going to plug it in to find the y coordinate. The y coordinate is actually 5/3 as well. So plug it in and check. So that's our steps for finding the altitude.